Wish my binoculars were as powerful as the Hubble so I could see it myself. Excuse me. A little chilly out here outside. Hi, everybody. I am Marquette, and you are stay curious today with some star curiosity on our special Monday program, Backyard Astronomy with me, Marquette. I got my finder chart up here in my planisphere. I got my red flashlight so that my eyes, once they adapt to the dark, don't go back to and contract down. They stay dilated so I can read things at night and not hurt my night vision. In my night vision tonight, in my own backyard, I will show you a planet here at the end of our Stay Curious, Star Curious program that actually has another planet going around it, a star in your own backyard, very close to Jupiter and Saturn up in our night sky. Don't forget Venus, the bright star right after sunset. You're not going to be seeing it in about 3 weeks. It'll be gone. Too close to the sun. Then it's going to pop up in the morning sky. But today we're talking about exoplanets. And this beautiful mural behind me is a painting depicting different types of planets that we've discovered orbiting other stars. Now, Marty Winkle, my cameraman and co-producer of Stay Curious, and our Trekkie Techie, Jessica Galloway, both said last week, told me some news stories that you may have heard in the news about a giant planet orbiting a massive pair of extremely hot stars, this planet being 10 times larger than Jupiter. And I love it when these capture the news headlines because astronomers in the last 25 years have discovered 4,000 planets orbiting the closest stars you see in your backyard sky. That means that most stars probably have planets orbiting around them, like our sun, which has 8 planets and a handful of other smaller bodies in it. Imagine the stars you're looking at night, counting all those stars you see, and that if every one of them has 3 or 4 or a dozen planets going around them, yes, there are more planets in the universe than there are stars in the sky. Wow, think about that. And we talk about 100 billion stars being in our Milky Way galaxy alone. All right. In the Andromeda Galaxy that you can see tonight, well, the moon's out, so you might have to wait for the moon to go away because it drowns out the faint stars like the Andromeda Galaxy we talked about a couple of weeks ago. You can see that with your naked eye in a clear, dark location that's 2.5 million light years away from us. All right. And it has got twice as many stars as us. And then you multiply, like Marty and I were talking in the pre-production meeting. The Hubble Telescope has revealed to us not thousands, but billions of galaxies in our solar system. So you run the numbers. Wow, there's a lot of planets orbiting stars out there. And we're looking at ones that can harbor life like the Earth. And I'm going to tell you a little bit how we look for those here in just a minute. Let's look at a couple pretty pictures here first. And the first one we have is, let me go back there. Exoplanets. And this is a beautiful poster that I wanted to credit the person involved with this poster so we don't get sued. Martin Varjek, a Slovakian graphic artist, came up with this poster of over 500 exoplanets that have been discovered in the last 7 years, all right? Now, these are visualized by artist conceptions. These are not photographs. We have yet to photograph the first planet orbiting a solar system. Well, sort of we have, and that's the one that's going around the star that you can see tonight, a star called the Lonely One. You're going to learn that star here at the end of our program. But this is 500 nearby planets. The sizes range from twice or 3 times the size of Jupiter to down to Earth size. How are these planets detected first? Well, the first detection is there are different types. There's the gas giants like Jupiter and Saturn. There's the Neptune size that are Jupiter and Saturn are in the 80,000 mile diameter range. Huge. And then the Neptune Uranus sizes are 30,000. That's quite a jump. So Saturn and Jupiter are both twice the size of Saturn and Neptune. Then you have the terrestrial Earth-sized ones that are made of rock and metal. And then they have super Earths, they call, over my shoulder here. These are like the terrestrial worlds, but even bigger, approaching the size of Neptune and Uranus. All right, 30,000 miles across. The Earth is about 8,000 miles across. Now, we do not visually see these with telescopes, several of which, including TESS, was launched just 10 miles away from us here at the at Cape Canaveral Space Force. That was a Falcon 9 launch a couple years ago. There's a telescope called Kepler, and TESS is the Transiting Exoplanet Survey Satellite. And it is looking for, like it says, exoplanets that are moving in front of their parent star. Okay? Well, someone needs to be on a smart tab phone here. Well, I'm going to continue with the program like we are rolling here, and hope we are, to show you that we do not see these visually. We infer them. And one of the first exoplanets were discovered by the tug back and forth that gravity does on a body. The Earth's planets, the solar system planets of the sun, tug it back and forth, all right? And this tug is very real and very, though very infinitesimal, it can be measured by scientific instruments on ground-based telescopes and other instruments like the Hubble Space Telescope. So, we were checking to make sure we got our glitch solved here, and we're good. Okay. So what we're looking at are inferences of these planets, not hard data imagery. That will come with the launch of the Webb Telescope on December 22nd. Marty, we're just a week away from launching the major observatory called the Webb Telescope, named after the great NASA administrator during the Apollo moon race in the 60s. So in a week, that's going to be launched, and about 3 or 4 months after it's launched and everything's checked out, we'll start getting some wonderful data. And some of the first things they're going for are the exoplanets, to see if we can see some of the globes of them, and that is a big priority. Okay, we're hung up there, Marty, on our.
No, wait a minute. You just hung up on the images.
Okay. We're trying to move our image to the next one here. It's a Monday at the American Space Museum. A few little technical problems. Please bear with us as we are frozen on my screen back there. What we are looking for are Earth-like planets, okay? And these Earth-like planets.
Yeah, we're good now.
Okay.
Okay, we're back.
The Earth-like planets are ones that we are called in the Goldilocks zone. We have over 4,000 confirmed exoplanets. This is a 2003, all right, not 2021. 18 years later, we've almost doubled this, all right. Number of confirmed are in the red, totals 1,000, okay. Most of them are giant planets like Jupiter, or even larger, super gas giants. The ones the size of Neptune, the first 70%, because we can use this as a gauge over, this is a true scale that has been continued now over to 4,000. About 70% of them are gigantic. Less than 15% are the size of Neptune. The ones the size of Earth are less than 10%. All right, of all the exoplanets are the size of Earth or super Earths, all right, are around, well, that'd be 1%. 11 out of 1,000 is 1%, and about 10% are super Earths. And this is also logical that we're discovering the larger exoplanets around stars first. We want them to be in the Goldilocks zone. And now we know that there might be this many potentially habitable planets, 2, 4, 6 times 4 is 24, 25, that we're for sure could harbor human life, or not maybe human life as we know it on Earth is what we say. These planets have an atmosphere, they have H2O on them, water, and they're in what we call the Goldilocks zone. That Goldilocks zone, like the old Grimm's fairy tale, all right, three bears are and Goldilocks wanders in their home of three bears, and the porridge that she's eating is too hot. All right, Papa Bear's is too hot, Mama Bear's is too cold, but Baby Bear's is just right. So that's what we call the Goldilocks zone, where the temperature is not too hot or too cold. It is just right, right in the wheelhouse of where water can be liquid on the surface of a world. Frozen is too cold, all right, to sustain life like we know it, but we know that frozen water, as it goes closer to the core of the moons of Jupiter that have a lot of frozen water on the surface, it becomes an ocean underneath. So the Goldilocks zone's important. Planetary atmospheres, astrobiology are new careers out there that have come from these studying these habitable zones. This is a great new career for science-minded youth that want to get into astronomy. And the TESS satellite, which was launched in April 2018 aboard a Falcon 9 rocket. Marty, we saw that happen from Spaceview Park. It has 24 unconfirmed worlds. These are it that could harbor life. Think about that. And these are within stars that are within the more like 30 light years of Earth. Very close stars. Again, Kepler is another telescope that is out there doing great science right now and finding habitable worlds. The M-class stars at the bottom are what our sun is like, an M-class star, and we've got 4 candidates of that. All of these candidates are going to be looked at closely when the Webb Telescope gets online, hopefully by next year. It's going to launch December 22nd, y'all, so 9 days from today. So again, Kepler has discovered a whole star system of potentially 3 or 4 candidates within a star system that could harbor life, and these are the artist concepts of those. Well, let's go out on our evening nights now here and look to the west, to the south. Okay, we're in Florida, so we're looking towards Miami. You up in Michigan, look down towards Florida, not Canada, okay? You're never going to see the planets, the moon, or the sun looking to the north, all right? Because the Earth is tilted. That if Earth wasn't tilted, all the planets and the sun and the moon would be directly overhead on the ecliptic, which is an extension of the Earth's equator. So we're going to be looking to the south, and you'll see bright Jupiter and Saturn after Venus is set, and there's going to be a star there called Fomalhaut. It's a very easy find star because it means fish's mouth, Fomalhaut. It is in Piscis australis, the southern fish, but it is also called the Lonely One, and it is a bright star that is kind of lonely because there's not many bright stars around it. But when scientists on Earth 10 or 25 years ago started getting into digital photography and doing things away from film, they saw a ring around Fomalhaut there in the center. And this ring is a primordial ring of planets being formed. And that blue coming out of it is gases being exhausted out of a solar nebula, if you will, an exosolar nebula of planets being born. And this is a very intriguing part of astronomy. And if we could see this ring, it would be 3 times the size of the moon. So it'd be easily seen or around the star. And then the Hubble telescope has even found more data, the location of Fomalhaut in the center, okay? And then you've got some technical jargon there with how this ring is rotating around, and we believe there is a planet being formed around Fomalhaut. They in fact called it B. You can see it there in the off my shoulder is the little inset, all right? And that inset is off of right there. This planet B is right here. It has already sprung off of this ring, all right, that if we could see in the night sky would look like that. And that's 3 Earth moon diameters across there, by the way. So that is in your own backyard looking at Fomalhaut, okay? The Lonely One by itself, and you can imagine as I am looking at Fomalhaut and seeing planetary system actually being created from your own backyard another world being created in front of our eyes around this star Fomalhaut. So science is just so strange. It's stranger than science fiction could ever be. And we're so grateful for the scientific tools like the spacecraft TESS and Kepler that were designed specifically to seek out in our night sky the wonders that are there for you to see. And though you can't see them as good as these telescopes orbiting Earth, you can look at them online and infer what we're seeing on there. So I should be looking this way. My hand's getting cut off. We're all mixed around here today, Marty, but that's okay. We were so glad that you were with us. We got Robert Milton, used 99 stars. Okay, thank you, Robert, for giving us this. Flying has followed us, and Joe Midwesterner has followed us. So thank you, Marty, for some of our new people reaching out on there. Beginning of the year, we're going to have some promotions for you to join us and not only share, like, follow, and subscribe. Stay curious, but how to tell your spacey friends to follow us, and we're going to have some gifts for you throughout the next month, much like a PBS fundraising event. So, and one of them gifts that I was talking with someone today are some rocks from the Crawler Way, okay, that could come your way. So, Marty, thank you for doing a great show. Jessica Galloway was streamed in with us remotely. We had a little hiccup there, maybe caused by our connection here with the internet. So glad for y'all to stay tuned with that. And Marty, we have any other comments? Anything else?
No, I just think we dropped out for a few seconds a couple times. but-
Okay. And that is inherent in today's busy world where we got internet all over the place. Well, we will pick up Stay Curious tomorrow with a wonderful conversation with a gentleman named Mark Goodkind. You're not going to want to miss this gentleman's tales from Gemini. He was a launch conductor. He wrote the launch procedures for Gemini 7 to be launched to Gemini 6 on December 15th, 1966. You are not going to want to miss a wonderful conversation with Mark Goodkind tomorrow on Stay Curious. And thank you to everyone here at our Space Museum who is wanting to see you in our museum here so you can bridge the space between us. I'm Mark Marquette, and we'll see you tomorrow with another Stay Curious conversation.